Okay. Yeah. Uh, Hi, Karthik. Can you hear me?
Yes.
Hello, I'm audible?
Yeah, Sundar, I can able to
Okay,
hear
fine.
you.
So, in the last class, we have seen about the linear regression details, right? So, just as an overview, so we have seen like, what is linear regression, gradient descent, and regularization, etc. Those stuff, right? So, today we are going to, move on to the next machine learning model, right? So, over here, sorry, yeah, let me put it away. Yeah. So now just I hope you remember this gradient descent concept, right? So same thing we'll be using in the logistic regression also. Okay. So now let's start with the logistic regression. Fine. So
Mm-hmm.
now to start with, you in one of the class when I was giving the overview about ML models. So I remember I was speaking about different categories of ML models. Like
True,
basically we
true.
have. Uh, you know we have regression models, we have classification models, and we have clustering
Mm.
models. You
Yes,
remember? So
yes, yes.
the difference is very simple. So basically in regression and classification, so we predict something, correct? So the only
Mm.
difference is the
Yes,
output variable. So if the output variable is
correct.
continuous, that will come under regression. Agree? Like
Yes,
continuous value, house price, or
yes,
age. Okay, some continuous value. And if there is no continuous value, but you need to classify some things, okay, good, bad, or yes, no, okay, pass,
yes, yes,
fail, fraud, not fraud, terrorist, not a terrorist,
yes,
something like that. That is classification. Agree?
correct.
So
Mm.
in the linear regression which we have seen, okay, so that will come
Mm.
under the regression concept. Okay, so
Yes.
in today's class we are going to see about the first classification algorithm, that is called as logistic regression. And
Yeah,
clustering is, in clustering we don't predict anything, so we'll just cluster into different buckets that we will see later on when we're discussing about the clustering models. Okay, fine.
sure.
So now see, before starting, right? So let me tell you. Oh, sorry. Mm, yeah, let me tell you. Logistic regression is a first classification algorithm which anybody will study, and honestly, this is honestly, this is not very straightforward to understand. Okay, but I'm
Mm-hmm.
not trying to scare you, but most of the people initially they will think, okay, they understand logistic regression, okay, but again after some time they'll realize they don't understand completely, then they'll come back again they will try to learn. Okay, personally I also
Mm-hmm.
took like 4 to 5 times to read and gather from different sources and to understand logistic regression. Okay, but
Mm-hmm.
the problem is it seems like simple, so that's the reason many people
Okay.
will think, okay, this is simple. Okay, but they say that if you understand logistic regression very well, so it will give you a very good foundation for you to understand many other algorithms. Okay, because I would say all other algorithms are basically easy. Okay, when compared to logistic regression, I'm not saying this is hard. Okay, but there will be some involvement of math. Okay, and few other
Mm-hmm.
stuff. Okay, but we'll try to understand it from scratch. Okay, I'll try to make it as simple as possible. Okay, but the basic thing is it is very interesting. Okay, we'll try to start it from very point zero, and then we'll try to understand what it is. Okay, fine. So now, yeah, as always, you can stop me in middle if you have any doubts, and make sure you understand it very well. Okay,
Okay.
yeah. And now to start with, when we are saying classification, the one single thing you need to keep in your mind is it is at the end of the day we are classifying the data. Okay, that means
Yes.
you have some classes. For example, you can have many classes, but let's start with two classes. Okay, binary class. That means only two sets. Okay,
Correct.
apple orange as a simple example, or in election whether that candidate will win or lose. Okay, or you
Yes.
applied for a loan, whether you will get loan, accept or rejected. Okay, whether a particular
Correct.
you are working in some bank and a technical team, and suddenly you saw a transaction, so whether that transaction is a fraud or not a fraud. Okay, or you got a mail,
Yes.
right? So Gmail, the very well example is in Gmail, so you have a spam folder, right? So you never gave any instruction to Gmail how to segregate or how to send the mails to spam or not spam, right? So automatically it is doing that, correct? The moment
Yes.
even if you open now, you will see a spam folder. How it is doing that? So it is a simple model running behind that. So with that, it will decide. Okay, so whether that mail should be sent into inbox or spam. Okay,
Correct.
so those things. So this is fundamental classification. Okay, so these can for these we have many classification algorithms like logistic regression. Next, we are going to study something about KNN. Okay, so as you can see here, so okay, and after that we are studying something called as SVM, as you can see here. Okay, so then we have famous decision tree algorithms. Okay, so there are different types of classification algorithms. Okay, but the first thing we are going to study is the logistic regression.
Yeah.
Got it? Okay, so the
Yes.
the basic plan is first we'll try to understand right from the intro or basic idea, and then we'll go into small maths, and then we'll go to see what is loss function, what is a logistic regression equation. Okay, and after that, once we get good understanding, then we are going to see something called as classification metrics, Karthik. Okay, what is classification
Mm.
metrics?
Mhm.
Just like in linear regression, if you see, we saw something called
Yes.
as metrics. Like what
Yes.
is
Yes.
basically,
Yes.
sorry, what is metrics? You built a model, that's fine. You understood all the max algorithm. You built a model. Now, how well that model is performing?
Correct.
Okay.
How good it is.
How
Yes.
good it is? Okay. What all metrics you need to consider? Okay. In just like how we studied few things like R square, adjusted R square in linear regression. Here also we are going
Yes.
to in the classification part also. Just to important point is when we discussed about these metrics are for regression metrics. Okay. Don't confuse. These are for
Yes.
only for
Yes.
linear regression. In future
Yes.
we will see other regression also. We have decision tree regression. Okay, we also have
Mm-hmm.
even for SVM also. Almost every classification algorithm can also be used for
Mm-hmm.
regression also.
Okay.
Okay, the other way is not true. Okay, for using regression we cannot do classification. Okay, but
Mm-hmm.
using classification we can do regression also. For example, we'll study something called as SVM. Okay, it's called support vector
Mm-hmm.
mission. Basically it is designed for
Mm-hmm.
classification, to classify, but
Mm-hmm.
using that we
Mm-hmm.
can do regression also. Okay, and mainly
Okay.
decision tree. Mainly decision trees are used for classification, but using that we can also do regression also. So all these metrics are regression metrics. Okay, you can use it for any regression algorithm. Okay, now coming back,
Okay.
uh, we have classification metrics also. Okay, so when I say classification metrics, that means this can be used for any classification model. This is not dependent on any one model. Okay, general classification
Mm.
metrics. Fine. And after
Yeah.
that, we will see something called as hyperparameters. Okay, so this is the idea. So first, we'll start with the intro. Okay, so
Sure.
now the first thing is when I'm saying, yeah, yeah. So first, let's try to understand the definition or Wikipedia definition of what is logistic regression. Okay, so I would say start with a blank mind. Okay. So just have the idea
Mm-hmm.
what is just a classification. Okay. Apart from that, just try to build one step at a time. Okay. So that at the end of few classes, once we complete, right, you will have good understanding of this. Okay. So now you see,
Sure.
logistic regression is a supervised machine learning algorithm widely used for binary classification tasks, such as identifying whether an email is spam or not, and diagnosing diseases by assessing the presence or absence of specific condition based on patient results. Okay, not very helpful. Okay, I'm just reading the definition, don't worry. Okay, but main thing is, but main
Binary classification. Yeah.
yeah, so it is saying this is a supervised machine learning algorithm, okay, which is widely used for binary classification. Try to understand this much. Okay, so as I said, in supervised we have regression classification. Okay, so this is classification. Okay, so that's why this
Yes.
classification is also comes under supervised. So it is saying this is a supervised machine learning algorithm. That means it can do classification. It is supervised means what? It can be regression or classification, but this is used for what? For classification purpose. Okay, this is used to classify certain things. Okay, just like spam or not, diagnosing diseases, etc., etc. Okay, the simple what we
Mm.
have just discussed. Now going forward. Okay, no, oh, sorry, what I'm doing is. Okay. Now, if you see, logistic regression used for binary classification, where we use sigmoid function that takes input as input independent variables and produces probability of 0 and 1. Okay. So I'm
Mm.
just
Mm.
reading this so that you'll have used to few words like binary
Yeah.
classification, sigmoid function. Okay. But each and everything we are going to see in detail. Okay. Don't worry. Okay. So what it is
Yes.
saying, this is a type of classification where we are using some function called as sigmoid function, and it will take some value
Mm-hmm.
and give you output of 0 and 1. It is saying. Okay. But
Yeah.
why we need to use sigmoid function, why it is giving probability, that we are going to see. Okay, fine. So for example, if you have classes like 0 and 1, if the value of logistic regression is greater than 0, it is saying is 1. If it is less than 0, it is saying is 0. Okay, that is all that is fine. Okay, now
Mhm.
Let's start with few important things.
Okay.
One important question. I think whenever you see in last 5 minutes, I was saying we are studying about classification. We are doing
Correct.
classification task. Okay. But
Yes.
what is the
Yeah.
algorithm we are studying?
Regression. Regression
Logistic
is the
regression.
thing.
Okay.
Hmm.
So I think you should get a doubt. That means, hey, you are
Yes.
saying,
Why it is
yeah, why it is called
regression,
regression?
but it is,
Correct.
yes.
Why it is called regression, even though we are doing
Yes.
using it for classification purpose. Okay. So when logistic regression does classification, okay, why it is called regression? It is not doing any regression. Correct. Correct. But still, we are calling it as regression. The reason is
Yes.
as follows. Okay. The main reason is, what
Mhm.
happens, okay, in logistic regression basically is, okay, I'm just giving an overview. So we'll pass an input, okay, it will give you some output value, okay, some number it
Yes.
is going to give. We are going to use some
Yes.
function, okay, that function is going to give some output, a value number. Using that number, okay, using that number we will classify the given output. Okay.
Okay.
I'm saying, okay, let's say in linear regression what we did, so we understood all that, least square error, everything, and finally we got some model called as linear regression model. Okay. Now what is the
Yes.
purpose of this linear regression model? You pass me any input, I will give you an output, one number it will give you.
Yes.
That is the purpose.
Yes.
You remember this, right? Now in
Yes.
logistic regression also what happens is, what how it is working inside we will see. Okay. But finally what happens is, you pass something input, a test input, it will give you some number. Okay.
Yes.
Initially a number is generated, some number. Based on this number, we will classify the this given input as class 1 or 2 or positive or negative or pass or fail, etc. and etc. Getting?
Okay.
If you
Yes.
see the final thing, what is happening? Classification is happening.
Yes.
Okay. But from the model perspective, what it is doing, it is giving you a number.
Correct. Same
Correct?
like as a
Regression.
linear regression.
Correct. Okay. So model job is to give out a number.
Our
After
job is
using that number, how we are going to classify, that is being done by us using some technique
okay.
that we will discuss. Okay.
Okay.
So,
Okay. Okay.
during those days, like when people are, discovering this, or inventing these algorithms, right? So they said that
Mhm.
first they have invented this linear regression. So what it is doing, it is giving number. After few months or years, I think the logistic regression came into picture. Okay, this is also doing what? This is also giving a number. So they just thought, okay, since this is also giving number, let's call it as regression. Okay, so
Right.
they started calling it as logistic regression. Okay, and after that, so many classification algorithms came. Okay, and but as time went on, people just left it like that. They did not try to change anything, because I'll give you an example. Okay, sometimes we'll start with something and later, even though it is not very apt, we'll start calling it the same way. For example, if you say, if I call you, hey, can you dial this number? Okay.
Yeah.
So, but actually, why it is called dial this number? In olden days, we used to have this dial phones. Okay, that means you
True.
have this
True. True.
number. You need to dial like this.
Correct.
In old movies,
Correct.
we can see, right? So that is called
Correct.
dialing. Okay, that's called. But now today's nobody is using. But still, we can say, hey, can you dial this number?
Yes.
Correct. Means once people got
Yes.
habituated, so there is no point of changing it, because even though then when you are saying dial this number, actually I'm saying is, hey, can you call to this number? Agree?
Yes.
Just like when they invented, it's called, they saw some similarity between regression and they just started calling it as logistic regression. Okay. But even though
Correct.
fundamentally what it is doing is classification, but after that they did not change
Classification.
anything. Okay. So
Change
this
the
would
name.
be one of the interview question, I would say, because I face,
Oh, seriously.
yeah, yeah, yeah.
Okay.
Fundamentally they will ask, because they'll test. Okay, see, fundamentally when you're doing classification, why it's called regression. Okay, so
True.
one person asked me in my interview, so, and it's a common interview question, I would say. Okay, so if you're able
Okay.
to say this,
Okay.
then you are good. Okay.
Okay. Hmm.
Just one second. Okay, fine. So now that is a small background, Karthik. Now we are going to start from the very scratch. Okay, ground zero. Now,
Hmm.
what is task in our hands? The task in our hands is simple. Okay, now forget about logistic regression. Okay, all this, okay, that will come. But the task is given two sets of data, you need to divide it. Agree? That
Yes.
is to classify
Yes.
in two parts. Simple. Agree? Now,
Yes.
how we can do it? So fundamentally, if you have two sets of data, okay, we have something called as perception trick. Okay, it is not a
Okay.
separate trick, but just using common sense also. What does it mean is, for example, if you have these two data, one is blue
Hmm.
data, one is orange data. Okay,
Yes.
now as you can see, mostly it is separable, linearly separable, but the only thing is you have some points over here, which should be here, and we have some
Correct.
points over here. Okay, that's fine.
Correct.
Now, yeah, I when I'm speaking about the logistic regression assumptions, okay, I'll tell you. But one of the assumption is, see, before that, let me tell you this. In linear regression, there is one thing you need to remember. Linear regression and logistic regression is,
Mhm.
in linear regression, okay, in linear regression, one assumption is the data should have a linear relationship.
Mhm.
Agree? That means if x is increasing, y should also increase, something like that.
Correct.
You
Correct.
remember, right? In logistic
Yes.
regression, okay, the data should be linearly separable. Okay,
Correct.
that means you should be able to separate it with a line. Okay, that
Okay.
means one
Okay.
side should be here, some side should be here.
Yes.
Okay, this is one other assumption. Because if you have this data, okay, if you have a data like this, Karthik, okay, okay, outside you have full x, one type of data, inside you have 0, 0, 0. Okay,
Hmm.
this is
Hmm.
not linearly separable because any line you draw, you cannot divide exactly
Correct.
two sets, right? So this is not linearly separable.
Correct.
Okay, so
Correct.
one assumption of logistic regression is that data should be linearly separable because here
Hmm.
also the model is line. Ultimately, in linear
Yes. Okay.
regression, you remember
Okay.
when we are discussing,
Yes.
finally,
Yes. It's a line.
what is model? Model is line. We are getting a line. That line
Line.
is called
Correct.
best fit line.
Correct.
In logistic regression also, finally, you are going to get a line. Okay, if
Okay.
it is in 2D, okay, if you are having higher dimensions, so it could be plane, okay, that we will see, okay, but basically it's used for binary classification. So here, finally, we are trying to find out a line which will separate the two data.
Okay.
Okay,
Okay.
fine. Yeah, with that, you see, you are having this data. Okay, how you can separate? So to divide a
Yeah.
data into two parts, we need a line. Okay, let's start with some random line.
Correct.
Okay, so what is the equation of the
Correct.
line? Y equal to mx plus c.
And it's plus two.
That is equation. The general form of
Hmm.
line is ax plus by plus c equal to 0.
Hmm.
Okay, these both are same actually, because if you can write this as this also, because if you see y, no, from here if you see what is y will become uh minus c by b, okay, minus a by b x.
Hmm.
Okay, just sending this and doing the simple math. Okay,
Correct.
so now this is same as this. So what is c here? C is minus c by b. Okay, and what is m here? M is minus a by b.
Correct. If you separate minus, you will get a x plus c.
Correct. Okay, so this is equation. Now if you see, we can start with some random line. Okay,
Hmm.
we can start with some random line, and when we can see whether it is classifying or not. Okay, then if it is not, then you go for another line, then you go for another line, like that.
Correct.
Basically, to start
Correct.
with, we can do that. Okay, but when you start with some random line and you can start shifting the line, okay, let's say you started with this line, is it class, okay, if this is a perfect line, you may not get this perfect line. Okay, for example, you started with some this line. Okay, you are saying, okay,
Mhm.
is this perfect? No, then you will shift slightly, then you will shift slightly, then you will shift slightly.
Correct.
Okay,
Correct.
basically, because if assuming that you don't have any tools in your hand as of now, okay, you don't have
True.
any.
True. True.
Okay, so now what happens with this? How many times you can do? Let's say you can do it for 1,000 times, or you can
Mhm.
do till all the points are correctly classified. Okay.
Okay.
But our common sense says that it is almost impossible, even if you do like 10,000 times also, sometimes you cannot get the perfect line.
True.
Okay.
True.
But before going into logistic regression, let's try to understand. Okay, we have started with some random line. Okay, let's say some random line.
Mhm.
We will see, usually we have two classes, right? One is class 1, class 2. Usually
Blue.
we call it as
Yeah.
positive
Correct.
class, negative class. Okay, in logistic
Correct.
regression, positive class,
Okay.
negative class. So which side is positive class, which side is negative class of a line? How can we decide? Usually, the above region of a line is called positive
Mm-hmm.
class, and below region of a line is called as negative class.
Mm-hmm.
Okay. So why? How can I say? Okay. So I'll just show you. Okay. For example, we have this site called as Desmos. Okay. Very
Mm-hmm.
helpful site. Over here, if you see,
Okay.
you draw any line. Okay. I'm see. This is a graph you are having. Okay. So you just
Mm-hmm.
draw. I'm drawing this line. 2x plus 3y equal to 4.
Okay.
Okay. So it is drawing the line. Fine.
Mm-hmm.
So now, which side is positive, which side is negative? I will just say 2x plus 3y plus 4 greater than 0. I'm saying, see here. Okay. If
Mm-hmm.
I
Mm-hmm.
activate this line, you see this region.
Yeah.
Okay. That means this region is positive region for this line. Okay.
Mm-hmm.
Means
Okay.
any
Okay.
value,
Got it.
any value
Mm-hmm.
in this region, you take that point and replace. That means, see, any point in 2D coordinates will have x and y.
Yes.
Okay. For example, what is this line? This is 10, 20, 10.
10. Mm.
Okay, x-axis 20, this is 10, 20, 10. Now take this point. What do you mean by this positive region? That means take this point and replace this 20 and 10 and do this, you will get greater than 0.
Correct.
Okay. And if you see less than 0, that means this line. Okay, take
Yeah.
any point here and replace the values x and y over here. You will get value less than 0. Agree? So
Agree.
any line you take, the above part will be positive and below part is negative. Okay. We are not simply saying
Yeah.
you can clearly see the graph. Any line you can take. Okay. You can just simply, after this class, you can go to desmos.com and experiment and play with it. Okay. So
Mm-hmm.
positive side will be upward region will be positive and downward region will be negative. Okay.
Okay.
Now, now the point is see. Now the actual cinema starts. So if you are having a line, okay, for example, here is a line. Okay. Now,
Okay.
see, let's say this above side is belongs to orange class, okay, positive,
Mm-hmm.
and below side
Mm-hmm.
belongs to blue class, negative. All this fine, but there are
Okay.
these points, right?
Correct. Blue and orange.
Right.
Yeah.
So this should actually fall here. This should actually fall here.
Correct.
Okay. Now this orange line will try to pull the line towards itself. Agree? Because if it
Mm-hmm.
pull towards itself, what will happen? If it pull, and after that, if it pull more, then that point will fall the other side of the line.
Correct.
Getting? Are you trying to visualize? Initially, it is here. If it pull, next the line will come here. The point is
Correct.
staying there only. We are not trying to change the point because
Yes.
that is the data. We cannot touch
Yes.
the point.
Yes.
Initially,
We are changing only line.
yeah, okay. Initially the line is here. The distance is more. If it start pulling, then the line will come closer. Again, if it start pulling, the line coming here. Again, it start pulling. Now the line, it has crossed the line. So now what?
Correct.
This point has moved to the positive side of the line, which is now
Yes.
correct. Because this
Mm-hmm.
point, orange, should be in the positive side, upward side. Because
Yes.
like all other points. Agree?
Yes.
Getting?
Yeah.
Okay. Now, the other way, now if you see this part will also do the
Mm.
same thing. It will try to pull towards
Correct.
the side. Okay. Initially here, then it will go here, then it will go here, then it will, if it goes here, that means this is falling to the negative side of the line, which is, then it is
Correct.
correctly classified.
Correct.
Agree? Now,
Yeah.
pulling of the line, how we are going to do this pulling of the line? Okay, how we can
Mm.
do that? That we will see. Now, if you see, we have understood like how we can label the given a line, how you can label the regions. Okay.
Mm-hmm.
Okay. See, before that, Karthik, I'll tell you one thing. So this what I'm explaining, right? So this is first I'm telling you without logistic regression, how we can achieve something. After that, then what is the need of logistic regression? Okay. See, I can directly
Correct.
simply
Correct.
tell you
Correct. Correct.
in
Got
10
it.
minutes what is logistic regression, and that will be done. Okay. But
Yeah.
keeping long time, okay, need in mind. So if you understand these things, right? So you will have, then
Mm.
you will truly appreciate why we are okay using logistic regression, how simple it is. Okay.
Okay. Okay.
Right. So now coming back, if you're having a line, so there is one now very, very important point we need to see. Here we see 2 points misclassified. Each point starts pulling
Mm.
the lines towards it. Okay.
Correct.
Now note that to move a line to positive region, we need to subtract the coordinates. And to move the line to negative region, we need to add the coordinates. Okay, this point if we need to understand. Okay, if you understand this, the remaining parts are very very easy. Okay, but what does that mean? Well, let's see. Now see, let me actually just take one more pen. Hmm. So what I'm saying over here is, just give me 1 second. So yeah. So yeah, see here. Let's say you have a point over here.
Mhm.
Okay, the x. This should okay. This should actually
Mhm.
be here. Okay.
Okay. So
Okay.
line
This
should be
should
below.
actually be here. Okay. So that means what?
Yeah.
This should fall here.
Correct.
Okay. So
We should
now
move the line below x. Yeah.
correct. Okay. So now what it is? So but for this line, this is negative region.
Mm-hmm.
This is positive region. The upside region is positive
Correct.
region.
Correct.
Okay. Now keeping this mind, okay, just let's try to
Mm-hmm.
see
Mm-hmm.
few things and come back. Okay, this is the line, and
Okay.
we also saw
Hmm.
the greater than zero is positive region and less than zero is negative region. Okay, this is fine. There is one important thing over here. These are the coordinates, right? So 2x
Hmm.
plus 3y equal
Hmm.
to 4. When we are
Plus 4. Yeah.
increasing the coordinates, that means if we are adding some value to coordinates, what happens? You see
Mm-hmm.
now 2x plus 3y. Now on
Mm-hmm.
x-axis, if you see, instead of 2, if you take 5, that means adding some
Mm-hmm.
value to the coordinate, x coordinate. If you see
Mm-hmm.
what it is happening, the earlier, see, earlier this much is negative. Now more part is negative. Okay,
Okay.
earlier only this much is negative. Now
Yeah.
this is also negative.
Correct.
Okay, that means what? That means what? If you are adding, so if you're adding the
Mm-hmm.
values,
More value.
you're
Mm-hmm.
adding the values, what you are doing, you are moving it towards a positive region. That means more negative region is coming towards your end.
Okay.
Okay. So if you see,
Okay.
if you try to understand, okay, if you are adding the coordinates, okay, to move the line to negative region, we add the coordinates. Okay, same thing happening
Okay.
earlier. You are having only this much negative. Okay, if this uh, color is confusing, okay, let me take this. Yeah. So earlier only this much is negative region.
Correct.
Okay. If you add the coordinates, that means 5x. If you add the coordinates, okay, you
Hmm.
are having more
Negative has been increased.
region.
Correct.
Okay. Similarly,
Hmm.
if you see, if you subtract the coordinates, that means instead of 2x, I take only 1x. Okay. Now this is
Okay.
okay. I'm just removing this line. I'm doing only 1x.
Mm-hmm.
Okay.
Oh.
If I'm doing 1x,
Yes.
okay. Now you see, for example, now you will get the idea. Let's say my line is here, x, the point,
Correct.
not line, my point. Okay.
Correct.
Actually,
Correct.
this should be in the positive region.
Hmm.
Okay. This should be in the positive region. Okay. X should be
Correct.
positive.
Yes.
But unfortunately, it is lying in the negative because all this is negative.
Correct.
Okay. For this
So
line.
in this,
Now,
yeah. Okay. Okay. Hmm.
now try to understand. Now, what I'm doing is instead of 2x, if I do only x, now,
Yeah. It fall on the
yeah,
positive side because
yeah,
yeah,
correct. For
we
this line,
reduced the coordinate value. Yeah.
below is negative, above is positive. Okay. With respect to
Hmm.
this new line, okay, with respect
Yeah.
to this new
Mm-hmm.
line, x is
Correct.
correctly classified. Agree?
Yes. Yes.
Because for this new line, the x is above, which is perfect because positive side, it is positive, so it should be on the above region. Agree?
Yeah.
That means what? To pull the line,
Correct.
okay, to pull the line, you need to subtract the coordinates.
Hmm.
Okay? And to push the line, we'll add the coordinates. In other
Okay.
way rounds, to move the line to negative region, we add the coordinates. Okay? The same thing we have done. Okay? The same thing we have done.
Hmm.
Uh, if you see, to when we are adding the coordinates, just a second, what we're doing, to move the line to negative region, we have added the coordinates, and to move it to the positive region, we have subtracted the coordinates. Okay. So same
Mm-hmm.
thing, if you see here, when we are subtracting, um, Where yeah. So from 2x to 1x. Okay, that means when you're
Mm-hmm.
subtracting the coordinates,
Mm-hmm.
okay. So we have
Mm-hmm.
added the positive region. That means what? Earlier only this much is positive, but now
Yeah, now positive
is positive.
increase. Yeah.
Okay.
Can you please, yeah, can you please go back to that
Yeah, sure.
definition
Yeah.
point?
To move the
No,
line
not yet.
to positive region, we subtract the coordinates. Okay.
Okay, fine.
Positive means you subtract. Okay. So if you see here,
Yes,
when we have
subtracted 2x
subtracted
minus
from
x. Yeah,
2x to x, when we subtract it, so it
yes,
moved to the positive region.
true.
For this line, it was in the negative region, but for this line, it is in the positive region.
Yes, understood. Got it.
Agree?
Understand.
Understood, right? Okay,
Yes,
fine. So
yes.
now, same thing for the other way around. So if it is the other way around, then if you
Mm.
want to move it to the negative region, we add the coordinates.
Yes, first one
Okay.
that we have seen. Yeah.
Correct. So now, if you understand this one point, so same thing you can repeat for all the points. That means every point you take, okay, if you see whether it is perfectly classified, that means actually see you take some random line, okay, may not be this line, any line you take that line, and from all the data set points, okay, first point you take, let's say you take this point, okay, you see whether as per the data set whether it is actually positive class or negative class. Okay, if it is negative class,
Okay.
okay. Now if it is negative class, whether it is lying below the line or above the line, below the line, then it's
Yeah.
perfect because it is a negative class and lying below the line, perfect. And
Mm.
other way around is if it is a positive class point and it is
It
lying
should,
above the
it
line,
should
that
be
is also
above the line.
perfect.
Yes.
Agree? But a
Yes.
positive class point lying below the line or a negative class point lying above the line is a problem.
Correct. In that case, we need
In
to
that case,
set
we
the
will try to
line.
shift it. Okay, how we will shift it?
Yes.
We'll take these coordinates. Okay, I told you
Yes.
just subtract the value, but how much you will subtract? You will subtract as per these
Correct.
coordinates. Okay, these are the coordinates
Correct.
4 to 1, 4 2. This is the line. Any random line you can take. Okay, these coordinates you will subtract from this so that you will get a new line. Basically, what is
Correct.
line? Line is y equal to mx plus c or ax plus b. Okay, x and y are variables. Correct.
Yes.
What are the constant values a, b, c? If you change a and b and c, you will get a new line. Correct.
Yes.
2x plus 3y plus 4 is one line, or 5x plus 8y plus 9 is another line. So to change new line, you need new a and b and
Yes.
c. Correct. From where you will get
Mm.
new a, b, c. When you subtract these coordinates from this value, obviously we are going to get a new value. Okay, that means new line.
Yeah.
Okay, maybe this line will shift over here and will become a new line like this. And for this new line, again, you will do calculations for all the points. And somewhere you will get an issue. And with respect to that, again, you will subtract the coordinates. From that, again, you will get a new line like this. Like that, the line will completely shifting and trying and experimenting. Finally, you will, if you're lucky, you will settle down. Is it clear?
Yes.
Any
Yeah.
doubts?
Clear. No.
Okay, fine.
Mm.
So now we have understood this, correct?
Yeah.
Now we can apply these transformations like add and subtracting and getting a new line. Okay, every time. But in ML, we don't do these big transformations at a time. So we gradually move the line. Okay, that means what? So when you subtract this 4 comma 2 from this line, you will get from 2, it will go to even from 2, even if it go to 1, that is also very big change in ML. Okay, because in ML, we'll do very minute changes like from 2 to very small change, like only change of 0.001. Slowly we'll change the line. Okay.
Okay.
Because in gradient descent, if you remember, we used learning rate, right?
Yes. Yes.
So to control the speed.
Yeah. Slow. Yeah. Yes. Yes. It should be
Okay.
go slow. Otherwise, it will change the point. Yeah.
Yeah, correct. I have it ready. Okay. Over here, if you see the direction is perfect, but the speed is more so that it is
Speed
crossing
is
the
more. Yes.
minima.
Yes.
That's why we introduced
It
what?
should
We
be slow.
introduced something called as can we see same thing?
Learning.
Can we move this fast in ML? No, we cannot move. Okay, that's why we introduced learning rate. That means you should slowly learn. You should
Learning.
learn, but very, very slowly you should learn.
Correct.
Okay, same thing over here also.
Correct.
We understood like how to do the transformation. I hope you understood like how you can check which side the point is falling, which
True.
positive, negative.
True.
You can change.
True. True.
Okay, you can shift the line,
Yeah, we
but
can change, but slow. Yes.
slowly. Okay, for that, what we'll do, you'll use a learning rate 0.01. Say you can use 0.001 anything, so that it will slowly
Okay.
shift the line. Okay, how we will do that?
Okay.
Let's see. Okay, for example, see, I've done this in my notes. Okay, just for time saving,
No problem.
attach this.
Yeah. Yeah.
Okay, so for example, if you see, consider this line 2x plus 3y equal to 4. Okay,
Mm-hmm.
and let's say this is the
Mm-hmm.
point 4 2. Okay, 4 2 is in this form, okay, y equal to mx plus c, it's called 4 2. If you use this ax plus by, the c will be 1, okay, 4 2 1. Okay,
Mm-hmm.
so this point is 4 to 1. So now from this line, okay, this is the line,
Mm-hmm.
and this particular point is the wrong classification. So now you need to change the line. That means we'll subtract the coordinates. Agree?
Mm-hmm. Mm. Yeah.
When we want to subtract the how we are going to do from this line, what are the coordinates of no, not values of line 2 3 4? Okay, 2 3 4 minus 4 2 1. You are going to do this.
Okay.
Okay, you will get minus 2 1 3. That means what? This is a new
Mm-hmm.
line. That means what? The new line
Correct.
will be minus
Minus
2x
minus 2x plus
plus
y plus
into y
3
y plus 3 equal
plus
to
3.
0.
Correct.
Okay?
So here, Santosh, I have a doubt.
Yeah,
So, uh, just from, okay, that is the line. Okay, fine. That 4 comma 2 coordinates of x, right? That is fall above the line.
correct.
Okay, that using those coordinates, we are generating new line. We are getting new line.
Correct. We are subtracting this
Okay.
value from the line, and
Yeah.
we are getting the new values of A and B and C for the line.
Okay. Okay.
Okay?
Hmm.
Now, this what are these values what we are getting? See, this 2 3 4 are what, Karthik? So 2 3 4 are A, B, C values of line.
Line. Yes. Yes.
So, but that line is not working 100% perfect.
Correct.
So we need to
Correct.
subtract some value. Why subtract? Because this is above the line. Okay. To move it into the okay positive region or negative region. So we had these rules and we are subtracting the values. Okay.
True. True. True.
Now subtract from these values so that we'll get a new line.
Correct.
Okay. From this 2, we are subtracting 4. That means, hey, this much A is not needed for me. I want to subtract my
Hmm.
4 and only minus 2 of A value is enough. Only 1 of Y
Okay.
value is enough and 3 of C value is enough for me. Okay, this is giving new line.
Yeah.
Okay.
Yeah. Yeah.
This line could, is your doubt clarified?
Yes. Yes.
Okay. So now this is a new line. Now, if you plot this new line, this could be somewhere. Okay. Maybe, I don't know. I'm just assuming this could be new line, this line.
True. True.
Okay.
True.
Now with
Mm-hmm.
this line, again, you will do check for all the points. Somewhere you will find the issue
Correct.
and that you will subtract
Correct.
it. You will get a new line.
Correct. Correct.
Okay. Like that, you will repeat.
Correct.
Agree? So now,
Hmm.
see here. But just now we told we are not going to do that because it will drastically change the line. So you're using a learning rate of
Hmm.
0.01. Okay. That means
Yes.
what? First, you will multiply this 0.01 with these coordinates and then you will subtract.
Mm-hmm.
That means what? If you see
Oh.
2, 3, 4, you're not directly subtracting 4 to 1, but first you will multiply this 4 to 1 with your learning rate 0.01. So 4 into 0.01 will
Okay.
be 0.04, 0.02, 0.01, and you'll get some coordinates that will be your new line.
Okay. Got it.
But as you can see, this is very small change
It's a
because
minimal. It's a
minimal
minimal. Minimal. Yeah.
2.0.04 is very small. That means
Yeah.
this
1.9.
we can guess. That means it could be very
Correct.
slightly somewhere like this.
Yes. Yes. Yes.
Okay.
Got it.
And is that going to work for this? No. Again, you will subtract slightly.
No.
Again, you will slightly. Okay. And then you
True.
can experiment this learning rate also. If you think that it is very slowly changing, then you can increase slightly. Instead of 0.01, you can say 0.1 or 0.05, something like that.
Yes.
Okay. So like that you can do. That is one way. Getting?
Yes. Yes.
Are we good till this point?
Yes.
Okay. So this we understood how we can start with some random line, shift it, and also control its speed. Okay. These three things we have seen. Okay. Using this, you can, if you have patience, you can sit and use some learning rate and then slowly shift the line and see where it is going to perfectly stop. Okay. Somewhere it will stop. It might take 100 turns, 1000 turns, 1 million, 10 million. After 10 million times, if you do perform this action, okay, turns, you might get that line. Okay. But obviously, we're not going to do that. If you do that, then what is the use of ML? Okay. But since we are seeing the basic intuition, this is one method. Brute force method, it's called. Okay. There is no technique involved in it. It is just a common sense. Agree?
Yes.
Okay. Now you see, now slowly we are entering into the actual core concepts. Okay. So now what happened? So the line is actually ax plus by plus c equal to 0. Okay.
Mhm.
So this can also be written as something w0 plus w1 x1 plus w2 x2 plus 0. Okay.
Okay.
Why? Because the simple logic why people use this, then this is, see, you have only a, if you are having only a b c, that's fine. But what if you have more features, okay, more dimensions, then you need to say ax by c cz d.
Okay.
Okay,
Okay.
instead of using that, if always getting into numbers is easy, so that's why you will say w1 w0 w1 w2. Okay, then you can, even
Okay.
if you have n
Okay.
dimensions also, w3 w4 w5, it's very simple.
Yes. WN. Yeah. Yeah.
Simple. Agree? Similarly,
Okay.
x and y, two. Okay. Now, if you have one more dimension, then you need to say x, y, z or x, y, z1, something like that. Okay. Instead of that, I'm saying x1, x2. Now, if you have one more,
Yes.
x3, x4, x5,
X3.
x6, simply I can say.
Correct.
Agree? Both these are same. Okay. But this is more easy to
Yes.
remember. Okay.
Yes.
Fine. So now, because if you see this line, if I write this, the main advantage is, so see, when you're writing like this, you can, instead of writing all this, you can simply write in this method. Okay, I have written the same.
Correct.
Okay, summation of w1 x1, and from I
Yes.
equal to 1 to n. Okay,
Got it. Hmm.
fine. Okay, so
Yeah.
now if you expand this, you will get this. Okay, or it could be 0 also. Okay, so you will expand w0 plus w1 x1 w2 x2, no matter how many features also you have, you will get those many values. Okay, you cannot write
Yes.
this if you use this one. Correct. So that's why more
Yes.
generalized form we are using this one. Okay. Summation of w1 x1 is
Okay.
the logistic regression equation. Okay. See,
Okay.
don't, we did not study actually what is logistic regression, but this is a fundamental line. Okay. The line
Correct.
we are trying to find out, right? So finally that will become a logistic
Hmm.
regression line. Okay. But the simplest equation is wi xi is our line. Okay. Yeah. Are we good till
Yeah.
now?
Yes.
Any doubts?
No.
Okay. Fine. So now understand, we got a line. Okay. With this equation, we draw a line. But how it is going to do the predictions?
Mm-hmm.
Okay. That is interesting. Okay. That we will go to see. So how it is going to do the prediction? It is also very simple. Okay. It takes the input and passes the value into this. Okay. And
Okay.
very simple, in the initial of the class only we discussed. If it is greater than 0, it is positive
Mhm.
class. If it is less
Yes.
than 0, it will be negative class.
Yeah.
The only thing is you need to get a line. If you get the line,
Oh.
just replace the values. If it is greater, if the value is greater than 0, it should be, the point should be in the positive class, or I will call it as positive class point. If it is less than 0, it is negative class. Agree? Same thing. It takes the
Hmm.
input value and does the wixi. That means what? See, now this, what is this equation? Let me write it here. W0 plus W1. Oh, sorry.
X1 W
Yeah. W1
1 X1
x1 plus W2
W2 H2.
x2 plus and so on. Okay. If you have,
Mm-hmm.
based upon how many features you have. Now x1, x2 are x and y, or two coordinates. Okay. Any point you are
Mm-hmm.
giving, right? So it will have two coordinates. In 2D, let's say you have only x1, x2. That points you will take and replace it. From where are we going to get these values? X1, W1, W0. As of now, just assume we are starting with some random line.
Yeah.
Agree?
Yes.
Okay. Finally, we will find out, okay, what are
Correct.
these values? Okay, and the whole game will revolve around this only, because now if you try to match this with the linear regression, there also what we did, our whole job is to find out what, to find out m and b values.
Yes.
You agree? So in gradient descent also,
Yeah.
if you see here clearly, what we're doing, we need to find out here is, you can say, m and b values, the best. Finally, what again, we are trying to find out
Line
just
only.
line. Okay,
Yes.
linear regression. What is line? Y equal to mx plus c. Now give me best lines of m and b which will have the least error. Correct?
True.
And that is the,
And passing through many points. Yeah.
that is the those values of m and b which is giving the least error. That is called the best fit line. Okay. Our whole job
Correct.
is to find out the m and b. Here also
M&B.
later we will see these values like w1, w2. Okay. General equation of the line. Okay. So now, as of now, what
Correct.
we'll do, we got this equation. So initially, if you want to do any prediction, what we'll do, so let's say some point, input point, you are saying, hey, Santosh, I have got this line. Okay. Now I'm giving you this point, 7.5, comma 6. Now tell me what is this prediction. So what I will do, I'll take these points and put it over here. Okay. So
Yeah.
W0 is some value. Assume that W0, W1, W2, we'll find out what are the best values. But as of now, any random line will have some values. Okay. Some random values these are having. Our job is to replace this x1 and x2 with your given points. Okay. So what I'm doing, W0 into 1, W1 into 7.5. Okay. And W2 into
Yeah.
6.
Yeah.
Okay. And when you do this equation, solve this, you will get some value. If that value is greater than 0,
Correct.
I'll say this is a
Positive
positive
class.
class. If the value is less than 0, I'll say this is negative class.
Correct.
Okay. But note we already know the values of W's. Okay. We'll see how to find this. Okay. Just assume we know the values of these W's. The prediction is simple. Putting it in the equation
Hmm.
and doing what? And I'm just solving and just saying greater than or less than 0. That's it.
Correct.
Okay. So now we'll start. See, you are giving me a point. I am putting it in my equation, and if it is greater than 0, I'm saying it is positive.
Hmm.
That means my line prediction is positive. That does not
Yes.
mean the point is actually positive. It is lying in the actual positive region. It could be lying in the negative region. My line could be a fault line as of line because I'm starting with some random line. It could be a very bad line. Agree?
Yeah.
So then what I will do? Oh, actually the line is, the point is a negative class point, but I am saying because my value is greater than 0, I'm saying is a positive class. So then I need to shift my line.
Yes.
Agree? Shifting concept which you
Agree.
have seen. Similarly, if you give some other point, if I get less than 0, I will tell, hey, this is a negative class point. I'll say. But
Yes.
actually, that could be a positive class point.
True.
Correct? But I'll say, okay, there is a difference between the actual and the predicted. So then what I will do? I will do some subtraction or addition and they will shift the line. Okay. So we'll start from random line and slowly we will do it for all the points. Okay. So same thing. So we start with some random points and then we're all take random values and we do WXI and we'll do the shifting. Okay.
Yes.
So now if you see, if WXI is less than 0 and Y equal to 1,
Mm-hmm.
okay. Uh, See, this could be,
Negative side. Yeah.
yeah, yeah. So don't get confused. So WXI is less than 0. Okay.
Yes.
That means what? That means what? WX is less than 0 means what? Negative region. Okay. So my,
Negative
my
region.
model is saying
Yeah.
it could be negative point.
Yes.
Okay. That means what? -1.
Correct.
But okay, you know, right? Because here the line,
Correct.
here it is equal to 0, the above will be +1, below will be -1.
Minus.
Okay. So if WXI, that means my line is saying less than 0, that means negative point, but actual Y is 1.
Mm-hmm.
This
Correct.
implies that the model is predicting as negative class, but whereas the actual is positive class.
Okay.
which means which means see the mod where actual label is positive class, that means what? Actual label is over here. This is a positive class, above is positive
Mm-hmm.
class, below is negative
Yes.
class. Okay.
Yes.
So actual label is positive class, that means it is over here, but the model is predicting as negative class. Model is predicting as negative class means what? The line is lying below the point is lying
Point.
below the line. Did you get confused?
Point.
Wait, 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 wait,
Point
wait,
is
wait, wait, wait.
line is below the point.
Yeah, yeah. See. First, I am saying WXI is less than 0. Just focus over here. WXI is less than 0. That means what?
Correct.
My line is saying the value I got is less than 0. When I will get the less than 0? Only when it, let's say this is my line. Okay. When I'm saying it is
Mm-hmm.
less
Mm-hmm.
than 0, only when the point is lying below this point, then only I will get less than 0.
Yeah.
Okay. All this is negative region. All this is positive region. Okay.
Correct.
For
Correct.
1 second,
Correct.
forget about what is the actual class of the point. Forget about that.
Yeah.
Just say my
Mm-hmm.
line is saying WIXI. I did this WIXI and I got this is -0 for this point. For your given
Mm-hmm.
point, when I do this calculation, I got less than 0. That means what?
Yeah.
That line is lying below the point is lying below the line. Only then you will get less
Oh,
than 0. Okay.
correct.
If the point is lying
Yeah.
anywhere here, it will be greater than 0.
True.
Agree? Now see.
Yeah.
Point is saying I did this calculation, I got less than 0. That means with this you can understand that this particular point is lying below the line. Okay. But the
Mm-hmm.
actual point
Mm-hmm.
is Y equal to 1.
Okay.
That means what? This line is predicting or classifying this as a negative class. Okay. Just because it is lying to this region or less than 0. But actually,
Mm-hmm.
this is a positive class. The actual ground truth is y equal to 1. That means what? That means what? This line, okay, this line needs to be
Mm-hmm.
pulled downwards
Yeah, below the point.
below the point. Because if it push this side, it will move farther and farther. Okay.
True, true.
That means,
Negative.
for
Mm.
example, if it is pushing this line, if it is going here, what happens? The above region will be positive, below region will be negative. Again, this point is falling in the negative region only. But that is not the goal.
True, true,
This point should fall in the
true,
positive region.
true.
Getting? So,
Yeah,
so what it should do, it should pull.
yes.
Okay, same
Pull
concept
down.
what we have studied. I'm just telling again. Okay, so it should pull towards it. That means what? It will pull towards it such that it will slowly come here. And finally, if it falls here, that means pulling means
Mm.
what? Every time it is pulling, the line is changing. That means the coordinates are changing. Getting right?
Correct,
So
correct,
earlier it
correct.
could be
Yes.
some,
In
I don't know what, 2x plus
0.0
3y.
point.
Then it will become some 1x,
Mm-hmm.
something. The line is every, if you are changing, going to a new line, new coordinates. That's it. Okay. So
Mm.
this line, this point is pulling. Okay.
Yes,
To pull, what we need to do, we need to add the coordinates. Okay. To pull,
yes.
we need to add the coordinates. Okay. If you add more and more coordinates, it will try to pull down so that the line will
Yeah,
go into the positive region.
correct.
Okay. Uh, to move into the positive region, which means we add the coordinates. Okay. Yeah. So if you see, we are adding the coordinates. Okay. So people might get confused over here. Okay. So
Mm-hmm.
yeah. See, if you have any confusion, so try to understand it this way. So we are adding the coordinates. Okay. When we are adding the coordinates, what is happening, Karthik? See, we are adding the coordinates.
Line will be become down.
Yeah. So
Both. Yeah, both are opposite, right? So if you add more coordinate value, line will be come down to the negative side. If we subtract the value or coordinates, line will be go up.
correct. That's exactly the point. Okay. So that is the reason what we are going to do here is if it is if the value is lying, okay, if it is misclassifying, I can say that means
Mm-hmm.
it should be actually in the positive region, okay, but the line
Mm-hmm.
is saying it is negative region, okay, that means it need
Yeah,
to pull downwards.
line
So
should come
we will add
down. Yeah, pull down.
and
So we have to add the
yeah,
coordinate value.
yeah, and the other way around is we will to subtract the coordinates we will do the other way around, okay. So the basic idea is
Yes,
that
yes,
now
yes.
using
But
this.
in this case, we have to add. In this
Correct.
case,
Correct.
yeah.
Okay. So now what we are going to do. So that means what? Yeah. Now we'll see. This is an important equation. So if you see here, if you are
Mm-hmm.
if the point is belonging to positive class,
Okay.
okay, the actual point is a positive
Mm-hmm.
class point.
Okay.
But WXA is what my model, my line prediction. No, we don't have any
Okay.
model yet, but just the line. WXA is our line. My line
Mm-hmm.
equation is saying less than zero.
Okay.
Okay. My line equation is saying less than zero.
Less than zero.
Okay. That means what?
Point should be below the line.
Point should be below. The point is actually
Below the
below
line.
the line. Okay. The point should be below the line. But the actual point is this point.
Below the line.
Okay. So we are adding the coordinates.
Hmm.
Okay. So
Hmm.
see the same thing. When y equal to 1, that means the point is actually a positive point.
Yeah.
But WXI is less than 0. That means WXI is less than 0.
Hmm.
Okay. That means we want the line to be pulled down. Okay. We want the
Correct.
line to be pulled down so that
Pull
this will
down.
move into this will fall in the positive direction.
Correct.
Okay. So we are adding the coordinates.
Coordinate.
Okay. That
Yes.
means the new coordinates will be old coordinates plus the
New
point,
coordinate value.
coordinate
Point.
value.
Yes.
Okay. But not directly, but we are multiplying with the learning rate.
Correct.
Okay. Same thing what we have done here. See, the new line, how
Yes.
we are getting the old coordinates are this. We are subtracting the new coordinates. What are
With
the point coordinates? What are the
the
point
learning
coordinates?
rate.
4 to 1. But we are multiplying with the learning
Yeah.
rate of 0.01 and then we are subtracting.
Correct.
Same thing, we are writing an equation. The new coordinates are
Yes.
old coordinates plus learning rate into the point coordinates. Is this clear?
Yes. Correct. Yeah. Clear.
Similarly, if the point is actual negative point, okay, that means
Hmm.
y equal to 0 or -1. So usually it will be -1, okay, or negative class
Mm-hmm.
is -1, okay. So let me, over here usually we
Yeah.
say
I
y equal
thought y equal to 0 means I thought on the line.
on the line. Perfect, perfect. Yeah, correct. Okay.
Hmm.
So if it is negative point, but the line is saying wixi equal to 0,
Greater than 0.
greater
Yeah.
than 0. Okay, that means what? In
Hmm.
this case, we have a line. This is a negative point. That means the
Point
point
is
is actually the point. Okay, first we'll see this. The line is saying wx is greater than 0. That means according to this line, the
point
point
is
is somewhere over here,
correct above the line.
positive side. But actually, the point is a negative point. That means it should be here. That means what? This should be pulled towards here so that the line will become here. Then this will become negative point. Okay. So it should be pulled towards this side. So in this case, we'll subtract the coordinates. Earlier case, the line should be coming down. This case, the line is going up. Okay. So here
Yeah.
the W new equal to W old minus learning rate into Xi.
Hmm.
Is this clear or any
Okay.
confusion? Tell me, man.
No.
Okay. Nothing. Same thing what we have done here in the equation in the max. Okay. How we are going to a new line from the old line. That's it. Just to summarize, we have the data set. You start with some random line. Okay, you started with some random line. Okay, with some that random line, you did predictions. How we are going to do predictions using these predictions, WXI. And if that value is greater than 0 or less than 0 is 1 point. What is the actual class of the point is another point. Okay. Now, if these two are same, that means, see here, this thing. That means the other two cases are anyway correct classified. That means what? If, see, WIXI is greater than 0. That means what is this positive class? And the line is, and the point is also positive class. Perfect.
Yeah. Yeah. Santosh.
The line is actually positive point. Now WXI is also saying greater than 0, positive. Perfect. In this case, we don't need to do
Yes.
anything. The line will not shift because perfect.
Correct. Yes.
Other case, WIXI is less than 0 means it is saying negative class point, and the actual also the
And
point is
point
negative class point.
point is
It is
negative.
also
Yeah. Here
perfect.
also no need to
The
put.
line will not shift
True.
anything because why it will shift when
True.
it is perfect. But when
Yes.
there is different cases like this, one is positive, another is negative, one is negative, other is positive, only then there is some error. Then only it will shift to
Correct.
correct.
Correct. Yeah. Got it.
For that,
Only
these
two
are the
cases in
equations.
total out of 4 cases. Yeah.
Out of 4 cases, 2 are perfect. Only 2 cases
Yes.
we need to shift it. Okay.
Yes.
That's why the other 2 cases are anyway correctly classified. There is no action needed. Okay. Only for these 2 error cases, we have these equations. Fine. So in a
Yeah.
nutshell, what happens now if you visualize the algorithm will start with some random value and it will start adjusting new W's. Okay.
Yeah.
Some random value you take off W of any value like 1, 2, 3, 0.5, so any value. You do these calculations for all the points and then you will get how you will get the new coordinate is this one. Old coordinates, this random values plus learning rate into that point, you will get new line, again new line, again new line. Whether it is positive or negative, how it is classifying, whether you need to use this equation or this equation. Okay. First you have some random line. Okay. If you're falling into this condition, you will add the coordinates this much value, then it will move like this. Again, after that, let's say you came across some this scenario, then you need to subtract the coordinates. Again, it will come down. Okay, like this, it will slide constantly shifting itself. Getting
Yeah. Santosh, getting. Fine.
clear right here?
Yeah. Yeah. Till now it's fine.
Okay. So now from here, it is after that there is only some basic maths. Okay. So instead of using these two equations, we can
Mm-hmm.
simply use
Mm-hmm.
one equation. That is this equation. So if you see, instead of using W new equal W old, one equation is W new equal to W old plus eta, sorry, learning rate of yi minus yi hat of xi. Okay. So this is one equation instead of two equations, and we can see this is using this. These two are also getting satisfied. How, for example, if you see, consider this point. Okay.
Mm-hmm.
If I
Mm-hmm.
say this scenario, wait, what this scenario? Okay, point is positive,
Mm-hmm.
but line is saying negative. Okay, from now on, I will use
Mm-hmm.
this word because you already know if I say this, that this means line is saying negative. Okay, this is
Yeah.
point is
Yeah.
positive. Correct. Here, point
Yes.
is actual
Yes.
negative. Here, the line is saying positive.
Positive.
Okay, so here, if you see this line, if you consider one case, see these two cases I'm not touching because these are happy cases.
Correct.
No need to do. We don't need to do anything. Okay, these are perfect. But two error cases are one is point is positive,
Line is negative.
but line is saying negative. So in this case, if you
Yeah.
try to use this equation, so what you will get W new will be equal to W old. Okay, see this equation. What I'm doing is W
Mm.
new equal to, okay,
W old
W old plus
plus
learning rate of
learning the.
yi. What is yi? Yi is the actual yi. Yi hat is a predicted yi. You know, right? We have
Yeah.
seen
Yes,
multiple.
sir. Yes.
What is the actual
Yes.
yi? I don't know. But how
Mm.
will I know from here? Actually, it is positive. That means one. Okay.
Mm-hmm. Yes.
Minus. Here we are saying it as a predicted yi. Okay. Predicted
Mm.
yi.
Mm.
Here it is 0.
It should
Okay.
be negative. Yeah.
Yeah. So
Mm-hmm.
into xi. So you will get
Yeah.
W0 plus eta of xi. Same
Theta.
as this one,
Okay.
W new equal to W old plus eta into xi.
Got it.
Similarly, if you see the other case, Wn equal to W0 plus
W naught eta
of,
x.
here in the case, point is negative. Okay. That
Yeah.
means what?
Line is positive.
Yeah. This is -1, but this is a positive. Okay. So
Mm.
this will become -0. So this will become -1. -1 into minus eta equal to minus eta minus eta into xi. Okay. So you're going to get W old minus eta into xi. So using this one equation, these two equations are internally getting satisfied.
Yeah.
Okay. Instead of using these two equations, I'll use only this one equation. Okay.
Got it. Mm.
Clear? Okay.
Yeah.
Fine. So now we understood that using perception trick. So all what we have discussed till now is some basic perception trick. Okay. There is no any
Yes.
machine learning. We did not learn anything. Okay. But it is simple. Started with some random line, how we can shift, how we can find out new values of n, w, how you can control the speed. Okay. How you can use only one equation. So we are able to find a line that classifies data. Okay. That's fine. But can we stop here? No. Why is this is good? Okay. But the problem here is this is not the best solution. Okay.
Okay.
The moment it thinks that, okay, it is classifying, it will stop there, but it will not push itself to find out the best solution. What do I mean it? I'll give you a small intuition. For example, if I say these are few points, okay, one class. So these are some other class Karthik. Okay. For example, you started with some random line. This is a bad line.
Okay.
Okay.
Mm-hmm.
You did all those calculations, WXI, then you moved little bit, then you moved little bit. Okay. The moment
Mm.
you came here,
Yeah.
okay, try to understand.
Yeah.
The moment you came here, as per the requirement, is it good or bad? Because one side of this are should be positive, one side of this should be
Yes.
negative.
Both are passively segregated. So it's
That's
as per
segregated.
requirement, it's fine.
Correct. So as
Yes.
per the requirement, this is
Yes.
perfect. I want this, I achieved
Correct.
this. Correct. So all
Yes.
these are negative class points segregated, positive class points segregated. The
Correct.
moment it does this, after that, once you achieve this, next step, if you do, again, if you take any point, okay, what it will do? It will do WXI. For example, see, just I will go one step back and I will explain you so that you will get a full picture. When you started with some random line, what it happened? For example, you started with this random line. Okay, so blue points are two blue points are below the line, perfect. Three points are above the line, perfect. But issue with this
Yeah.
particular point. So it will
Correct.
calculate the coordinates and it will try, and this point will try to pull towards it. That means the line should go up.
Yes.
Then only the point will come down. Agree?
Yes. Yes.
Okay. So it will do. Then slowly it will move like this learning rate. Then it will do like this. At one particular stage, it will come here.
Correct.
Agree? The moment
Yes.
when it came here, okay, the moment when it came here, okay, now again what it will do, but The line doesn't know whether it is perfect or not. What it will do again, it will ask every point, hey, what is, give me your point. I will do WIXI. Okay. The job of this line, what it will do, WIXI. That's it.
Okay.
Agree? For this point,
Yes.
WXI, perfect. Less than, the point is actually negative. And you'll also get WXI less than 0. Perfect. For this point also perfect. For this point also perfect. This also perfect, perfect, perfect. Everything is perfect. Then what is, it has no job.
Hmm.
Correct? It will stop here.
Yes.
Because
Yes.
when there is no error, why it will work?
Yes.
Is it clear?
Clear.
But the problem is in ML, we don't want solution. We want the best solution, optimal solution.
Okay.
Correct? So there
Yes.
also we want in linear regression also, we don't find the line. We want the best fit line.
Best fit line. Yes.
That means what? No other line should be better than this line. That means no other line can give
Correct.
lower error than my line. My line should be the
Correct.
line which is going to give me the least error. You
Correct.
remember? I was saying this many times in
Yes.
the
Yes.
here also, but
Yes.
can you guarantee over here, this is the line that the best line that is separating these 2 points? No, right? Because there could be some
No.
line over here.
Correct. Correct.
Because this line is better than this line.
Hmm.
Because what if tomorrow, if new data, if let's say new year,
Correct. Correct.
you're working in a
Correct.
company, new year, new data. If you're using this line, okay, for example, if you're using this line, and let's say new data came and it is falling over here, a new blue point,
Correct.
a new blue point came and fall over here. Sorry.
Yes.
Oh, so, yeah. So it, oh, what happened? Oh, sorry, man. Oh, sorry, sorry. Yeah. Okay. So fail over here. So this line is working fine? No. Again, it should adjust itself.
Correct. Again, we
Correct?
need to do.
Correct. So, but what if you have a better line? For example, if you have a line which is maximum separating, so then this line
Hmm.
will work for this point also. That means
Yes.
you
True.
want the line which separates maximum, not
Correct.
just the bare minimum. Okay. If you
Correct.
just
Correct.
talk about achieving the requirement, yeah, this is also achieving, this is also achieving. But in ML, you want to optimize the best solution. Agree?
True.
But the problem with this line is whatever the technique we have used, that is fine. Okay. It is great that we started with basic without any, okay, like tools or techniques or ML. We start with basic line. We understood how you can shift it, positive region, negative region, how you can shift from one line to other line, how to update the coordinates, learning rate, all that is fine. Okay. But the problem here is this is not the best solution. The moment the last point is classified correctly, the trick stops. It will does not improve any further. Clear?
Yes.
Okay.
Clear.
And okay, okay, and just we'll just check till here. So here we have 4 cases. Just I said, this is a yi is actual yi, yi hat is the predicted. Okay, so now yi minus yi hat. Okay, so for example, if you see actual is 1, predicted is also 1, difference is 0. Okay, actual is 0, predicted 0, difference is 0. Okay, actual predicted some difference, actual predicted some difference. Okay, the if you see just now we have seen, right? So when we are seeing over here, for the last 2 cases, we see a difference. These 2 cases,
Yes.
correct? Over here, it is perfectly fine. The actual is same as predicted. So what happens, just like I said, I was saying that, see, there is one important point you might have observed here. This particular line, okay, this is the
Mhm.
main reason why we will study logistic regression. Okay, try to understand this. Okay, are we
Okay.
good till now? Any confusions we have?
Yes. No. No. No.
No, right? Okay. You see here. When you are having this line, Karthik, okay, so when you are having this line, this is okay, okay, we are achieving the goal. But before that, let's say your line is here, okay, your line is here,
Okay.
okay. Now, what is our rule? You have some line, you'll ask each and every point, okay, and if that point is not perfectly classified, you will shift the line, correct?
Yes.
But here there is a fundamental problem. That means what? For example, if this line is asking this particular point, if it is starting with this particular point, then
Mm-hmm.
it is good because this point is wrongly classified. Then there will be some calculation, and the line, there is a possibility for the line to move up or down, mostly up.
Correct.
Agree? But
Yes.
let's say you have this random line and it is considering this particular point.
Correct.
Then
So it thought it is already below the line.
it is already below the line. So the line equation is wi xi. This line equation, this will have some coordinates x1, x2. It will put inside, it will replace over here. And this is let's say
New line.
-1 class. And this is also, you are getting it as -1.
Correct.
Both are perfect negative class, negative class.
Zero. Yeah.
Correct. Okay. There is
Hmm.
E. So the line will think, so what will be the next step of line? If this, there is, see, initially the line is over here. From here,
Correct.
at least it should change a little bit also. What it need?
Correct.
It need to subtract the coordinates
Correct.
or add the coordinates. But when it will do,
Yes.
only when there is some error, then only
Correct.
that particular point will try to push or pull towards it or away from it, right? But
Yes. Yes.
when you are considering this point, Karthik, this is perfectly classified.
Hmm.
As per the line, it is -1.
Yeah.
Actual also it is -1. So the point is happy, line is happy. The point will not try to push or pull. The line will also not do any effort. Agree? There is
Yeah.
no subtraction, addition. There is no learning rate, nothing. The line will stay like that.
Got it.
Are you getting?
Yes.
Same thing. For example, let's say it is checking with this point. This point is positive class
Hmm.
and WXI will also be positive. So the point will say, I'm
Yeah.
happy. No need of adding, subtracting. Just stay
Yeah.
as you are. The line will also say, okay,
Yeah.
fine. So from that particular point, there is no motivation for the line to move even an inch.
Okay.
Correct?
Yes.
If it is not moving, then how? Then where is the learning? Only when
True.
there is some misclassification, then only some
And
addition, subtraction, some calculation will take place, and then only it will try to shift to its position, right? But the problem
correct. Correct.
over here is whenever you are having a classes like this, like wherever it is perfectly having these values, see, when we are seeing a
It will stop
difference,
over there.
yeah, for the last two cases, we see a difference, hence the line shifts. Okay, this is good.
True.
So that we'll get a best line. But for the first two cases where yi equal to yi hat, we get in this case, yeah, interestingly, what will happen? Wn equal to w0 plus, this is the equation, right? The equation, the one single equation. Same equation I
Yeah.
wrote here. Okay. Over here, if
Hmm.
you consider for this particular case, what will happen? So the new coordinates of the line, Wn will be what? My old coordinates. Okay. From here, for example, wherever the line is there, plus learning
Mm-hmm.
rate into what is my actual yi? Even if you take anything, the actual y is 1. Okay. The line is also predicting it as 1.
Zero.
0. So this whole thing will become
So
0.
old equal to new.
Correct.
Old equal to new.
Old equal to no. That means what?
New
What is old
update.
equal to new? That means the old coordinates of the line, new coordinate. That means indirectly we are saying the line is same, the line, same line.
Yes.
It is
Yes.
staying in the same
Yes.
place. There is no movement.
Yes.
If it is staying, that means there is no update
Correct.
in the weights. That means these values.
True.
Means the line is not
True.
shifting
True.
at all. That means it
Got it.
got stuck. Thus, there is no learning at all.
Yeah.
Agree?
Got it.
That means the line is not learning at all. It is there. So we'll get stuck. So even though our perception trick is fine, everything is fine, but the moment when we face these situations, okay.
True.
But interestingly, here the issue is being caused by whom? The good guys.
Positive. Good word. Yes. Yes.
These are the good guys. For example, these guys are the bad guys because these guys are having some error. The error guys
True.
are helping because they are trying to shift the line.
Yes.
But the good guys, whenever you come across any good guy like this guy or this guy, all these three guys, they will say, I'm happy. No shifting. The line will stay like that. Okay?
They
Then
want
there is no
others don't
learning.
want to change. Yeah.
Agree?
Yes.
Fine. So that's the reason. But if you see what is the fundamental reason why we are facing here, the main reason is because you are getting the zeros over here. Agree? Because when you are having
Yes. Yes.
these values exactly 0, that's why this value is becoming 0, then this whole thing is becoming 0, then wn equal to w0 we are getting. Okay. So we don't want this to be exactly 0. So the problem here is, see, the issue we are facing here is when we are predicting the output function exactly as 0 or 1.
Hmm.
Okay. That is when we
Hmm.
are losing this equation. So, but instead of using that, if we have some other function which will, instead of giving exactly 0 or 1, if it is able to give a value between 0 and 1, but not 0 and 1,
Oh,
in
got it.
between 0 and 1, but never 0 or 1. Okay.
Yeah, slight change, whatever
Slight
the thing.
change it
Yeah.
will be. Okay. So even
Hmm.
though it is perfect, it will never tell it as, it is never tell it as 0. It will
Hmm.
tell very close 0.001.
Correct.
Even if it is 1, it will not tell 1. It will say 0.999. In that case,
Got
there
it.
will be
There will
slight
be
learning also, even in the happy case also. You getting?
true, true, true.
Okay. So one of that function is called as sigmoid function.
Okay.
Okay. So what it is
Yeah.
that we will see in tomorrow. Okay. But just I will show you so that you will have clarity. So sigma, there is one function called sigmoid function. What it is, tomorrow we'll see. But if you see sigmoid function range, it is 0 and 1. And you see these brackets. So these are
Right.
exclusive, that not including. So if you say like this square brackets, that means including 0 and 1.
Inclusive.
But if you say this flower
Exclusive.
brackets
Exclusive.
or parenthesis, not flower, parenthesis, this is not including 0 and 1. That means it could be 0.00001, not 0. And here also
Yeah.
0.00009 it could be, but not never 1. Okay.
Mm-hmm.
For example, if you see this graph, okay, if you see this graph, I'll just see here. As you can see, is this clear for you? This
Yeah.
diagram?
Yeah. 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 I can able to see. Yeah.
Yeah. So as you can see here, this is not touching 0, it
True.
looks like touching, but it will not
It's
never
not, I
touch.
think.
Okay. Here also the
Yes.
maximum value is 1. Okay. But it will never touch 1. Okay.
Correct.
See here, this is x-axis, correct?
Hmm.
This is y-axis. Okay. No matter how much you increase the x-axis, the graph, this is sigmoid value. Okay. Initially,
Okay.
if your sigmoid value, this is sigmoid function. Okay. So if the x-axis is 0, it will be 0.5. Y will be 0.5. Okay. If you keep
Yeah.
on increasing the value on x-axis, it will also increase. Okay. But
Hmm.
it will feel like it will touch the y-axis. That means 1. But no matter, even if you increase to 10,000 or 1 CR also, it will not be equal to 1.
That's the line. Yes.
Okay.
Yeah.
Correct. Here also, if you decrease the values, it will try to, decrease the value. It will become 0, 0, 0, but it will never become 0. That means any time it will be between 1 and 0, 0 and 1 only.
Yes.
Okay.
Hmm.
Getting? And that is exactly what we
Yeah.
want.
Yes.
Okay. That is exactly what we want, because the whole problem here we are facing here is, it is fine, but
It's
when the
because
value
of
is
zero and
becoming
one.
exactly 1 and 0, that means when we are predicting
Hmm.
1 and 0, it is becoming 0, then whole thing is going into waste. But if you want
True.
something which is less than 0, sorry, slightly greater than 0 or less than 1, if it is falling in that range, so obviously this will never become 0. You getting?
True.
This will never become 0. That means you will have some value that will get multiplied with learning rate. And then you will have at least slight, this WN will never be equal to W old. There will be slight change. So the line will at least slightly, it will change. Slightly, there will be some shifting. And finally, it will become best line. That we'll see how. Okay. But the reason, so now initially in the first initial class, so we studied that. So if you see here, the logistic regression where we use sigmoid function, okay, which will take input and produce some value between 0 and 1.
Yeah.
Getting? Why sigmoid function? Because, and why we want between 0 and 1? The reason is because if you're getting exactly 0 and 1, it is failing. So that's why we need a function, okay, which
Which
will give
will
you
not give.
between 0 and 1, and that one function is sigmoid function. Okay.
Got it.
Is this clear?
Yeah. Clear.
Okay, fine. So that's for today. Okay, I would say. So this is the basics. Oh, okay. I would say so. Tomorrow we'll see the actual logistic regression. So this is, I would say, background intuition of logistic regression, and why we'll use a sigmoid function. Tomorrow we'll see, what is why we'll use logistic regression, sigmoid function, and what are its benefits. And then using this, how then when we use this sigmoid function, you will get a new line. So how that will do predictions. This, our basic WXI is doing predictions in this way, right? Like
Yes.
replacing and giving the values. And tomorrow we'll see how this sigmoid function will do predictions and what are the benefits of that, and etc. and etc. Okay. Okay, man. That's all for today. Yeah. You have any doubts, or are we good?
No. No. Yeah. Good. Till now it's good.
Okay, man. Okay. I'll just end the class. Thanks, man. Bye.
Yeah. Thank you.